What if the biggest innovations of the last century, from that tentative 12-second flight at Kitty Hawk to planting a flag on the moon, happen not over a lifetime, but like in the blink of an eye?
Mm-hmm.
What if that breathtaking exponential speed, what if that's now your baseline? Your everyday reality for change in the business world, from steam engines to sentient systems, every breakthrough reshapes how we work, live, and lead. And it all starts with understanding emerging technology.
Yeah, absolutely. Today, we're undertaking a really critical deep dive, especially for anyone focused on building a successful career in modern business.
Right.
And, especially for those concentrating on information systems, on strategic innovation, we're pulling core actionable insights directly from Dr. Joseph H.Schuessler's essential text, Emerging Technologies and Innovation Strategy, the 2025 edition.
Okay.
Specifically, we're diving deep into Chapter 1, Technology Through Time, How Innovation Shapes Civilization. So our mission today is really to understand the history of this technological acceleration. We need to define how entire paradigms get, upended.
Completely flipped.
Exactly. And most importantly, we want to extract the core strategies on how you, as future IS professionals, as future business leaders, can not only navigate all this change, but actively steer it, for competitive advantage.
Absolutely. And if you're listening, maybe you're a student prepping for your career, or perhaps a professional aiming to stay ahead of the curve. Please, take just a second right now to like, subscribe, share this deep dive.
Yeah, that really helps.
We're giving out practical insider tips based on leading strategy texts, stuff that can absolutely position you for a bright future. And definitely check the description too. We've got links to additional resources there that'll help you cement these concepts for your studies, for your career prep. Okay, so let's start by painting that picture of technological speed.
Yeah.
The source material uses this really powerful illustration of acceleration.
The Kitty Hawk to the moon example.
Yeah, exactly.
Yeah.
Picture 1903, Kitty Hawk, North Carolina. The Wright brothers, they achieved humanity's first powered flight.
Just barely, right? A fragile thing.
Totally. A fragile wooden biplane lifting off the sand dunes for just 12 seconds. It was like a curious, tentative experiment. Now, fast forward just 66 years. That's less than a single lifespan.
It's incredible when you think about it, 66 years.
And suddenly it's July 1969. Neil Armstrong steps onto the lunar surface. He says, one small step for a man, one giant leap for mankind.
That arc, it's so dramatic. From a 12-second hop off a sand dune, basically, to navigating the vacuum of space, walking on the moon. All within 66 years. That's the ultimate illustration, really, of the breathtaking compounding pace technology can move at.
Yeah.
I mean, if you were a kid in 1903, flight was maybe theoretical magic.
Pure fantasy.
But by the time you retired, supersonic jets were, normal. So the core lesson here, especially for modern business and IS professionals like you listening,
Right,
is that technology evolves rapidly. It doesn't wait for you. And its exponential nature means it can just upend entire industries almost overnight.
It really is the difference between, linear progress adding one thing at a time and this exponential acceleration where the progress itself just keeps speeding up.
Precisely. And understanding that fundamental speed shift, it's basically mandatory for every single strategic decision you're going to make in your career. You have to get it.
Okay, so to really appreciate the warp speed of today, we kind of have to look way back at the incredibly long history of innovation.
Right. It didn't start with computers.
Not at all. At its foundation, technology is, it's simply the application of knowledge, tools, skills to solve problems. That's it.
And that's inherently human.
Absolutely. It goes back to our earliest ancestors. They were technologists when they figured out how to craft a stone hand axe to cut more efficiently.
Or controlling fire.
Exactly. Mastering fire was huge.
And the impacts, even way back then, they were profound, weren't they? Like control of fire. It wasn't just about warmth.
No, not at all. It massively expanded early human diets, allowed them to cook food.
Made it easier to digest. Right, which historians connect to all sorts of things. Greater safety, maybe even fueling larger brain development over time. That's technology fundamentally reshaping biology, reshaping society itself. And that societal shift, it just kept going profoundly. Think about the agricultural revolution.
When we stopped wandering and started farming.
Yeah. When nomadic tribes settled down, started farming, they created something new. a surplus of food.
Extra food.
That surplus was the economic engine. It freed up some people from just basic survival tasks.
So they could do other things.
Exactly. Specialize in trades, governance, maybe even systematic invention down the line. That's where civilization really started to, coalesce.
And you see progress accelerating them with later ancient inventions, like the wheel, right, around 3500 BCE.
Huge invention, and
Yeah.
it wasn't just for transport initially, crucial for early pottery making construction.
Okay.
Then later, figuring out how to smelt bronze and then iron, that changed everything again. Warfare, agriculture, craftsmanship, completely transformed.
So these ancient technologies, they basically unlocked new ways to organize societies, feed bigger populations.
They laid the groundwork. But maybe the most crucial shift for the long-term progress was when technology became the way we shared collective knowledge itself.
Ah, like writing.
Exactly. Writing systems were the start, obviously. Record-keeping, laws, that sort of thing.
But the real amplifier.
The real amplifier of human intellect, was the printing press. When Johannes Gutenberg perfected his movable type press in Europe back in the 1450s, that kicked off an information revolution.
Before that, books were super rare, right? Expensive.
Incredibly rare. Knowledge was guarded by scribes, really only accessible to the elite. Books were artifacts.
So the printing press, it basically changed the cost of copying information, made it almost zero for the first time.
Pretty much, yeah. The marginal cost plummeted. It enabled mass production of books. Suddenly, knowledge could be disseminated widely, quickly.
And that fueled things like the Renaissance.
Absolutely. Fueled the Renaissance, provided the common groundwork needed for the scientific revolution later on. It essentially magnified collective human intellect across continents, across generations.
Okay.
That mechanism is what really set the stage for the kind of acceleration we see today.
But it's important to remember the contrast, isn't it, between that huge jump and the thousands of years before it. The source highlights that for millennia, progress was often really gradual, sporadic, sometimes even stagnant.
That's right. Technical knowledge was often guarded, kept as trade secrets within craft guilds.
Right, protect your livelihood.
Or innovation was just stifled by tradition. The goal wasn't always improvement. Often it was just faithfully reproducing the old ways. And we even have historical accounts suggesting active resistance to innovation. It shows that technology isn't just about engineering efficiency.
Like the steam engine story.
Exactly. The sources mention suggestions that prototypes for steam engines might have been suppressed back in ancient Alexandria. Why? Because they would threaten the existing slave labor economy. It's a crucial lesson. Technology only gets adopted if it kind of aligns with the social and economic structure of the time.
But once the printing press really got that global exchange of ideas going, the underlying mechanism changed. Technology became cumulative, intentionally cumulative.
Right. Each generation now consciously inherits and tries to improve upon prior knowledge. And once you hit that critical mass, enough scientific understanding, widespread communication, enough economic capacity.
A tipping point.
Kind of a tipping point, yeah, roughly before the 18th century. Once those conditions were met, the stage was set for the accelerating change we're living through now. And that cumulative nature, it leads us to a really crucial business takeaway. Why do some brilliant inventions take off while others just fizzle out?
Good question.
Because innovation doesn't happen in a vacuum. To succeed, the source emphasizes you need three crucial things to align, all at the same time.
Okay, what are they?
First, there has to be a felt need or demand, a market motivation. Someone has to actually want it.
Makes sense.
Second, you need available resources. That means capital, materials, skilled labor to actually develop and implement the thing.
Got it.
And third, you need a supportive social climate. An ethos, you might say, that's genuinely open to adopting disruptive change, not fighting it.
That makes me think of Leonardo da Vinci. The source mentions him, right?
A perfect example. Back in the 1490s, he sketched these absolutely brilliant designs for flying machines, centuries ahead of his time.
The genius was there.
Undeniable technical genius. But the ideas just languished. Why? Because the social resources weren't there.
Like materials.
Exactly. The materials for light, powerful engines didn't exist. The scientific theory of aerodynamics wasn't developed, and there was no funding for such, risky, fantastical projects. Without that alignment of resources and social climate, genius just stays as a sketch on paper. But conversely, when those factors do align, technology spreads. It diffuses. We call it technological diffusion.
Like along trade routes.
Historically, yeah. Think about paper making. Started in China, spread across the Silk Road, which then enabled literacy elsewhere.
Okay.
Sometimes you even see simultaneous invention, like Isaac Newton and Gottfried Leibniz independently developing calculus around the same time.
Why does that happen?
Probably because the intellectual climate in Europe, the shared knowledge base, had just reached a certain threshold of complexity. The time was right.
But the scale of diffusion today, it's just fundamentally different, isn't it? Because of the internet. Global connectivity.
Oh, completely different. The isolation of invention has basically vanished. A breakthrough in deep learning from some university lab.
Yeah.
Or maybe an open-sourced encryption algorithm from a startup. It can be published, distributed, analyzed, improved upon by millions of people globally almost instantly.
Wow.
Progress isn't just a local thing anymore, it's a global network effect. And that network itself is accelerating collective innovation. It feeds on itself.
Okay, so technology builds on itself. Sometimes slowly, then maybe suddenly faster. But that progress, it isn't always just incremental improvement, is it? Sometimes the fundamental rules just change completely.
Exactly. And that brings us to a really crucial concept, the paradigm shift. That term, paradigm shift, it comes from Thomas Kuhn's work back in 1962. And it's key to understand this isn't just an upgrade. It's not just a slightly better version of what you already have.
It's something totally new.
It's a fundamental change in the basic concepts, the basic practices. It replaces the dominant technological common sense. It creates a whole new model, a new way of doing things that makes the old approaches basically obsolete.
Like the example from the source about personal transport. The car started as a horseless carriage.
Right. They tried to frame the new tech in the old paradigm, but the car wasn't just a faster horse, was it?
No way.
It fundamentally changed geography. It enabled suburbs. It created massive new infrastructure needs as roads, oil pipelines, gas stations. It freed commerce from being tied only to rail lines and waterways.
So the automobile paradigm, it basically wiped out the old way, like blacksmiths, harness makers.
Completely destroyed those industries. That's creative destruction, driven by a paradigm shift. Or think about computing. We shifted from those huge, centralized, room-sized mainframes.
That only experts could use.
Right, that was the old paradigm. We shifted to personal, decentralized computing in the 1980s. The affordable microcomputer.
The PC revolution.
Exactly. It empowered individual users. It created entirely new categories of applications, like the spreadsheet. Think about how that changed financial planning forever.
Yeah, VisiCalc, Lotus 123.
It was a complete reframing of computing power. Suddenly, the user, not the expert, was the point of control.
And understanding that reframing, that's crucial for organizations to survive, right?
Mm-hmm.
Which brings us to that, well, definitive case study in the text, the fall of Kodak.
Oh, Kodak. It was such a painful irony. It really should be required learning for every single business student, every IS student.
Why? What happened?
Well, Kodak was practically synonymous with photography for generations, right? Film, cameras.
Yeah, Kodak moment.
Exactly. But their demise was a classic textbook failure of managing a paradigm shift. The incredible irony is that their own engineer, a guy named Steve Sasson, invented the first digital camera prototype.
Kodak invented it. When?
Way back in 1975. They had the technical know-how in-house years before any competitor even came close.
So what did management do?
They shelved it, basically put it in a drawer. Why? They were afraid it would cannibalize their incredibly profitable film business.
Cannibalize, meaning hurt their own sales.
Exactly. The thinking was something like, well, digital quality is poor right now, and our film profits are massive, so let's just stick to what we know. Let's make film even better. That mindset, it proved absolutely fatal. And this is where we really need to apply that deeper organizational analysis, that IS lens. The failure wasn't just technical, it was a profound failure of the entire information system.
How so?
Kodak's whole organizational structure, its people, its processes, its technology, it was all built around chemicals, around fixed capital, physical distribution. Think about their assets.
Huge factories.
Massive factories, sophisticated chemical labs, a global supply chain just for film and paper.
Yeah.
These huge fixed physical assets. They actually acted as a strategic inhibitor. They couldn't pivot easily.
So they were kind of victims of their own success. Their main strength, chemical engineering, film production, became the thing holding them back.
Precisely. It became the heaviest burden, preventing them from crossing that digital threshold. It's the ultimate painful lesson in organizational inertia. And it gets deeper. Think about their internal reward systems. That's the process pillar of IS, right?
Okay.
All their internal metrics, manager bonuses, everything was aligned to maximizing film market share. Nobody got rewarded for developing a digital product that, at least initially, had zero marginal profit on the media. There was no film to sell.
So the incentives were all wrong for the new paradigm.
Completely wrong.
Wow.
Meanwhile, agile competitors who didn't have that legacy infrastructure, they just seized the new digital market. Kodak eventually filed for bankruptcy in 2012. A giant fallen.
Wow. That raises a really tough practical question, though. For any future executive listening, if you're running a successful company, how can you possibly justify killing your highest profit product line today? The one paying all the bills, keeping shareholders happy. How do you justify ditching that for some speculative, maybe low-margin future product that sounds almost impossible?
It is the single hardest strategic decision in business, no question. But look at Kodak. The alternative is often certain death in the long run.
So what's the insight? How do you do it?
The insight is that you must differentiate between making things better, incremental improvements, which Kodak did relentlessly with film, and disruptive innovations, which they ignored.
Okay.
Disruptions always start small. They often look low quality, maybe even unprofitable at first, but eventually they get better, they accelerate, and they conquer the mainstream market. The organization that survives, it's the one willing to cannibalize its own old lucrative models itself.
Before someone else does it to them.
Exactly. It takes incredible strategic foresight and immense courage to accept those short-term losses, maybe even angry shareholders, for long-term survival in the new paradigm. It's also really vital to remember that these big shifts, they take time to fully play out. They don't happen overnight usually.
Right.
Think about the move from landlines to mobile phones.
Yeah, that took a while.
Decades, really, from those big, clunky 1980s car phones.
The bricks.
Right. To the transformative pocket supercomputers we all carry today. It evolved.
Yeah.
So this is why major shifts, like the one we're in now with artificial intelligence, can be genuinely hard to recognize fully while you're living through them. It's unfolding around us.
Yeah, speaking of AI, the rise of machine learning definitely feels like a massive shift. We're moving away from programming computers step by step, explicitly,
Right, the old rules-based paradigm.
to systems that learn from massive amounts of data and become, well, autonomous. It's like moving from a paradigm of logic and rules to one based on probability and inference.
That's a great way to put it. And these shifts, they go way beyond just the technology itself. They actually reshape our societal mindset, our expectations. Think about the internet paradigm.
Instant information.
Exactly.
Huh.
Instant access to global information, instant online social connection. That became the universal expectation. It changed what we consider normal.
And paradigm shifts always cause that creative destruction, right?
Always. Old jobs, old industries get destroyed, but new ones emerge, often leading to huge leaps in productivity eventually.
So the moment you, as a student or professional, encounter a significant new technology, you have to immediately put on that strategic lens. You have to ask, what core assumptions does this challenge?
Good question.
Does it challenge my company's business model, our supply chain, the skills our employees need, and, importantly, what new problems does it create?
Ah, the downsides.
Yeah. Like cloud computing, it solved huge scalability issues, right? But it also created massive new problems around data governance, security, vendor lock-in.
Yeah.
Doing that kind of holistic analysis, opportunities and challenges, that's what turns just knowing about a technical upgrade into a real strategic advantage.
Okay, so if paradigm shifts are about changing the fundamental rules, then the Industrial Revolutions, they're like those paradigm shifts happening on a civilization-wide scale, right? Massive, sweeping transformations that define entire eras.
Exactly. They reshape industry, the economy, society itself. And when we look at this framework of the four major industrial revolutions, maybe the most compelling takeaway is the pattern of time compression.
Meaning they're happening faster.
Much faster. The first industrial revolution, starting around the 1750s, it took maybe 150 years to fully unfold its effects.
Okay.
The second, starting around 1870, maybe took 70 years. The third, the digital one, starting mid-20th century, maybe 40 to 50 years.
And the fourth, the one we're in now.
It feels like it's hitting us full force just 20 or 30 years after the digital revolution really took hold. The time interval between these profound society-altering shifts is shrinking dramatically.
Yeah.
Exponentially even. Wow. Okay, let's maybe dive into each of those four epochs. Focus on the defining technologies and how they basically reorganized everything.
Sounds good. Let's start with Industry 1.0, roughly 1750s to the mid-1800s. This was the era of water and steam power. The big shift was moving production out of homes and cottages and into centralized factories.
Mechanization.
Exactly. It really kicked off with the mechanization of textiles inventions like the spinning jenny, the power loom. But the absolute core technological driver was James Watt's improved steam engine, patented in 1769.
Why was that so important?
Because it allowed us to convert heat energy into mechanical work reliably, efficiently, and relatively cheaply anywhere. It wasn't tied to rivers like water power. This is what truly shifted economies from being agrarian based on human and animal muscle to being industrial based on machines. It established a whole factory system.
Okay, then comes Industry 2.0. Roughly 1870 to maybe 1914, right before World War I. This is the age of electricity, steel, and mass production.
That's right. Think Thomas Edison and his work on electric lighting and power distribution, and Nikola Tesla's crucial breakthroughs in AC power transmission, which allowed electricity to travel much further.
And electricity was better than steam.
Oh, much better for factories.
Yeah.
Cleaner, safer, way more flexible. You could run efficient electric motors almost anywhere in the factory, not just near the big steam engine. And that very flexibility enabled the ultimate optimization tool of that era, the assembly line.
Henry Ford.
Henry Ford perfected the moving assembly line around 1913, and that process optimization was incredible. It slashed the time needed to build a Model T car from over 12 hours down to about 90 minutes.
Wow.
That standardization, that scale, it made goods like cars affordable to the masses for the first time. It really created our modern urban consumer culture. Plus, you had global communication revolutionized by the telegraph and then the telephone, tying the world together commercially like never before.
Okay, then Industry 3.0. This one feels more familiar, starting maybe the 1950s through the 2000s. The digital revolution.
Exactly. This is about electronics, IT, and automation. If Industry 2.0 automated muscle power, Industry 3.0 started automating information handling and control.
What were the key technologies?
Foundational ones were the transistor, invented in 1947,
Tiny switch.
which led to the integrated circuit, the microchip, and that caused the subsequent explosion in computing power from those room-sized mainframes down to microcomputers and eventually PCs. You also saw automation advance with the first industrial robot arm in 1961. This whole era created what we call the Information Society. It totally transformed white-collar work with tools like word processing, databases, spreadsheets.
Things we take for granted now.
Absolutely. And then the arrival of the internet and the World Wide Web in the 1990s connected all these computers globally. That set up the framework for everything from e-commerce and complex global supply chains to the knowledge-based work structure that really defined the turn of the millennium.
Which brings us right up to today, Industry 4.0, the present. And the defining word here, according to the source, is fusion, right?
Fusion. Yeah, that's the term Klaus Schwab from the World Economic Forum popularized. It's about the blurring of the lines between the physical, the digital, and even the biological realms. And the defining technologies of this fourth industrial revolution, or 4IR, they aren't just individual breakthroughs. It's really about their convergence, how they work together.
Like what?
Like artificial intelligence and machine learning, obviously. The ubiquitous Internet of Things, billions of connected sensors, 3D printing or additive manufacturing, autonomous vehicles, and major breakthroughs in biotech like CRISPR gene editing technology. It's the interplay between these things.
So what makes this current revolution, 4IR, really different from the others? The source material points out three key characteristics, doesn't it?
It does. Three things make 4IR distinct. First is velocity. The sheer pace is exponential. It's driven by things like Moore's law finally hitting other fields, and the rapid compounding of data we can now collect and process. AI capabilities aren't just getting better linearly, they're taking these massive leaps forward in really short intervals.
Faster than ever before.
Much faster. Second is scope. Unlike past revolutions that might have initially impacted just manufacturing or transport, 4IR seems to be touching every single industry simultaneously. Healthcare, finance, agriculture, logistics, entertainment, everything.
Okay, velocity and scope. What's the third?
The third is systems impact, or that idea of fusion. This is maybe the most complex one. Technologies aren't just sitting next to each other anymore. They are merging, fusing together to create entirely new, often self-managing systems. Let me try to expand on that fusion idea because it's important. Imagine a fully autonomous supply chain in the future.
Okay.
It's not just about having robots in a warehouse that's more Industry 3.0 tech.
Right.
In a 4IR scenario, you'd have IoT sensors embedded in the raw materials themselves. These sensors continuously feed data location, temperature, maybe quality metrics to a machine learning algorithm and AI.
Okay, real-time data.
This AI then dynamically adjusts the robotic manufacturing process on the fly, and maybe it optimizes the delivery route for a fleet of autonomous trucks or drones in real time, reacting to weather or traffic, all potentially without direct human intervention.
Wow.
That's technological fusion. Multiple 4IR technologies merging to create a new adaptive self-optimizing system.
That contrast across the different revolutions really hits home when you think about daily life.
Yeah.
The source uses the simple example of just lighting your home at night. Let's walk through that.
Yeah, it's a great illustration. So back in 1750, before Industry 1.0 really got going, you relied on candles, maybe oil lamps. They were expensive, dim, probably smelly. Your whole day, your whole life really was dictated by the rhythm of the sun. Light was a luxury.
Okay.
Fast forward to 1890, mid-industry 2.0, you'd likely have access to gas light in cities or maybe early centralized electric bulbs. Light became much cheaper, brighter, cities lit up, factories could run 204/7, and you could communicate almost globally in minutes via the telegraph. Huge change. Then jump to 1970, mid-industry 3.0. The typical home was just saturated with cheap, bright electric light. You had all sorts of labor-saving electrical appliances. Color television was common. Routine air travel was a thing. The world felt much more interconnected, maybe through landline phones.
Yeah. Very different feel.
And now, 2025, deep into Industry 4.0, you've got smart LED lighting, probably controllable by a voice-activated AI assistant that's integrated into your home network. You carry a literal supercomputer in your pocket, your smartphone. Your health might be continuously monitored by wearable sensors. And the idea of autonomous cars driving around isn't science fiction anymore. It's a daily reality being tested and deployed.
It's incredible. So the ultimate takeaway here is that each industrial revolution didn't just change the machines we use. It fundamentally altered our expectations, what we consider normal.
Absolutely. Our expectations of convenience, speed, connectivity have been constantly reset higher and higher. We now demand the immediate, the interconnected, the intelligent in ways people just couldn't have imagined even 50 years ago.
Okay, so we've established this idea of time compression, things happening faster and faster. But let's try to quantify that a bit. The source has data on how long it takes new technologies to reach, say, 50 million users. Yeah. And that really shows the acceleration, doesn't it?
Oh, the statistics are genuinely mind-boggling when you line them up. Think about radio, a massive foundational technology, right?
Huge.
It took about 38 years to reach 50 million users.
Yeah.
Okay, then television came along, took 13 years. The internet needed only about 4 years to hit that same 50 million mark.
Getting faster.
And then you get into the purely digital, network-driven economy. Remember the mobile game Pokemon Go back in 2016?
Yeah, it was everywhere.
It hit 50 million users in just 19 days.
19 days from 38 years.
From 38 years for radio down to 19 days for a mobile app, that acceleration curve.
Yeah.
It just shows how the fundamental rules of technological diffusion, how ideas spread and get adopted, have completely changed.
And this incredible quickening pace, it's not just happening by accident, right? It's being driven by several interconnected forces that are themselves exponential.
Exactly. It's a confluence of factors. First, you have global connectivity and network effects. Because of the internet, ideas spread instantly, globally. But maybe even more importantly, many modern digital technologies benefit massively from something called Metcalfe's Law.
Metcalfe's Law. Okay, what's that?
Basically, it states that the value of a communications network, think social media, the internet itself, is proportional to the square of the number of connected users, n squared.
Okay, let's unpack that for a second. Why n squared? That sounds important for understanding this hypergrowth.
It's critical. Imagine a tiny network with just 2 people. There's only one possible connection between them, right?
Right, A to B.
Now add just 2 more people, so you have 4 total. Suddenly, you have 6 potential connections. A to B, A to C, A to D, B to C, B to D, D, C to D. You only doubled the number of users, linear growth, but the number of potential connections, and therefore the potential value of the network, grew much faster exponentially. This creates a powerful feedback loop.
How so?
More users make the system more valuable, which attracts more developers, more content creators, more businesses, which in turn attracts even more users. It's this explosive growth curve you see in successful platforms.
Okay, second major driver. The fundamental shift from atoms to bits. Or think of it as digital versus physical reality.
What does that mean?
Scaling up the production of physical goods like manufacturing millions of cars or laying thousands of miles of copper telephone lines that's slow, it's expensive, it requires huge amounts of capital and physical resources.
Right, building factories, digging trenches.
Exactly. But digital products, software, apps, music streaming information, they can be replicated almost perfectly, almost instantly, at near zero marginal cost.
Zero cost to make another copy. Pretty much. And they can be distributed globally in seconds via the internet. Removing those physical constraints of atoms is a massive, massive driver of the speed we see today.
Okay, third driver. There are simply more inventors, and we have compounding knowledge. Innovation isn't just happening in a few labs in rich countries anymore.
No, it's a worldwide distributed enterprise now. Millions more minds working on problems globally. And critically, we're all building upon an exponentially increasing foundation of accumulated knowledge.
The source mentioned something called the knowledge doubling curve, Fuller's idea.
Yeah, Buckminster Fuller observed this trend. He estimated that up until around maybe 1900, it took centuries for the total sum of human knowledge to double. By the early 2000s, some estimated that doubling time was down to maybe a year or two.
And
Now, with the explosion of data from IoT, from computation, from digital records, some forecasts suggest that in certain specialized fields, the relevant knowledge base might be doubling in a matter of months, or even potentially hours. Now, that doubling in hours idea is, maybe on the extreme end, but the implication for you as an IS professional is immense. Each new generation of innovators has exponentially more information, more data, and more powerful tools available to them than the last.
so we can build faster.
We can replace slow, expensive physical experimentation with rapid, cheap computational modeling. Think about drug discovery or material science, where scientists once spent decades painstakingly synthesizing and testing compounds in a physical lab.
Yeah.
Now they can use AI and supercomputers to simulate thousands, even millions of possibilities in days or weeks. It dramatically accelerates the pace of scientific discovery itself.
Which leads right into the fourth driver you mentioned, technology accelerating itself.
Exactly. The classic example is Moore's law. The observation, which held true for decades, that the density of transistors on a microchip, essentially, computing power for a given cost roughly doubles every 18 to 24 months.
More power, cheaper, constantly.
This sustained, predictable, exponential improvement in our core tool computation provides increasingly powerful, increasingly affordable tools for innovators, which in turn fuels the next wave of disruptive breakthroughs, like the recent boom in deep learning AI, which simply wouldn't have been possible without the massive, relatively cheap processing power Moore's law delivered. But we need to add a dose of reality here, a counterpoint. Not every single new technology gets adopted instantly, or even succeeds at all, which is why business students, IS students, absolutely need to understand the Gartner hype cycle.
Ah, the hype cycle. Okay, what's the gist?
It's a model that tracks how technologies mature over time. Typically, a new tech breakthrough triggers a peak of inflated expectations. Everybody gets super excited, media hype goes crazy, investment pours in, often way beyond what the tech can actually deliver at that point.
Sounds familiar.
Then, inevitably comes the trough of disillusionment. The technology fails to meet those wildly inflated promises. Early projects fail. Investors get scared and pull back. The media declares it dead.
Okay, they crash after the hype.
Right. But then, if the technology has real potential, it slowly starts to climb the slope of enlightenment. People figure out realistic use cases, the tech improves, best practices emerge. Eventually, it might reach the plateau of productivity, where its benefits are widely understood and it becomes mainstream.
So it's a cycle of overexcitement, disappointment, then realism.
Exactly. Early virtual reality is a perfect example. Huge hype in the 90s, then a long trough. Now it's finding real applications. The key behavioral insight here is that people, investors, the public, even companies tend to overreact twice. Once when they're too excited, and again when they're too disappointed.
And the job of the IS professional?
Is often to navigate that trough, to cut through the hype and the disillusionment, focus on genuine enterprise value, and figure out if and how the technology can actually solve real business problems, even when it's not fashionable anymore. And it's interesting, even fields you'd think are constrained by physical reality, like biology, are showing this kind of non-linear acceleration now. Think about the Human Genome Project.
Yeah, that was huge. Took years, right?
Took 13 years, cost about $2.7 billion to sequence the first human genome. Today, you can get a genome sequenced in under a day for maybe a few $100s.
Wow, that's faster than Moore's law, isn't it?
Dramatically faster.
Right.
It shows that once certain foundational scientific or technical barriers are broken, acceleration can happen almost anywhere, not just in computing. The development speed of mRNA vaccines during the pandemic is another example of rapid acceleration when urgency aligns with new platform technologies.
Okay, so the practical takeaway here for you listening, the learner, seems absolutely clear. Acceleration is the new normal. It's not slowing down.
Not likely, no.
So continuous learning. It's not just a nice to have, like a suggestion on a performance review. It's basically the absolute necessity for survival in your career.
Absolutely paramount. The cutting-edge skills you have today might be commoditized or even obsolete next year or the year after. So agility, flexibility, the ability to rapidly reskill and learn new things, that has to be central to your personal career strategy.
Okay, so technology is getting incredibly powerful, incredibly fast. But as that power and velocity increase, the potential consequences, both the good and the bad, they just skyrocket, don't they?
They absolutely do. And that brings us to a really fundamental truth, maybe an uncomfortable one. Just because we can do something technologically doesn't automatically mean we should.
The ethics lag behind the tech.
Exactly. Ethical reflection, societal consensus on rules, it almost inevitably lags behind technological capability. We invent first, and then we grapple with the consequences. And this challenge, it's not new. It's as old as the industrial revolutions themselves. You can look back to the Luddites in the early 19th century in England.
The ones smashing machines.
Yeah, they were skilled textile workers protesting new weaving machines that were replacing their livelihoods. Now, history often paints them as just being anti-progress, afraid of the future.
But it was more complicated.
It was arguably more a moral plea. They were raising legitimate concerns about the social fallout, the job displacement, the human cost of rapid, unmanaged technological change.
And the power of that technology only grew, leading to even bigger ethical dilemmas. The most stark historical example has to be nuclear technology, right?
Absolutely. The same fundamental scientific breakthroughs gave us both massive potential for clean nuclear power generation and nuclear weapons capable of unimaginable destruction.
A true double-edged sword.
The devastation seen after 1945 forced an immediate, massive global reckoning. Scientists, world leaders, philosophers, they had to confront the profound ethical consequences of this unprecedented technological power. That led to things like arms control treaties, international agencies, ethical manifestos like the Russell-Einstein Manifesto. The lesson was clear. Higher power demands higher ethical stakes. And as computers and information systems started becoming widespread in the mid-20th century, pioneers in computer ethics began recognizing the huge social and ethical implications that IT would eventually have.
People saw it coming.
Some did. But society often remains reactive, doesn't it? Think about privacy laws. They often get written or strengthened only after some major incident of personal data misuse hits the headline.
Right, we react to scandals.
Which means today's innovators, today's IS professionals, really have a responsibility to shift from being reactive to being proactive. We need to try and anticipate possible harms before deploying new systems, not just clean up messes afterwards.
So looking at the Fourth Industrial Revolution, the one we're in now, the source highlights 4 key ethical flashpoints that every IS professional, every business student really, needs to get a handle on.
Yeah, 4 big ones stand out. First is privacy and data ethics.
This feels huge today.
It's massive. With the ubiquity of IoT sensors, smartphones tracking everything, connected systems everywhere, the amount of data being collected about us is just unprecedented. Our location, heart rate, search history, social connections.
And that data can be misused.
Absolutely. It can be weaponized. The Cambridge Analytica scandal was a wake-up call for many. It showed how detailed psychological profiles built from seemingly innocuous personal data could potentially be used to manipulate opinions and influence elections. So for IS professionals, understanding and ensuring compliance with regulations is absolutely mandatory. You need to know about things like the EU's GDPR, the General Data Protection Regulation, which has become a global benchmark.
GDPR sets strict rules.
Very strict rules on data collection, consent, user rights. Systems have to be designed to meet these requirements. But ethics goes beyond just legal compliance, right? It demands genuinely respecting user consent, minimizing data collection, and ideally building privacy-preserving systems right from the design stage. Privacy by design.
Okay, privacy is number 1. What's the second major ethical flashpoint?
Second is algorithmic bias and AI ethics. This is becoming critical as AI systems move from labs into the real world, making decisions that have huge impacts on people's lives.
Like what kind of decisions?
Everything from who gets approved for a loan to who gets screened for a job interview, even potentially informing criminal sentencing recommendations.
Oh.
The major issue here is that AI is typically trained on historical data, and historical data often reflects past and present societal biases.
So the AI learns the bias.
Exactly. It inherits and can even amplify those historical biases. We've seen research, for example, showing that some facial recognition technologies have dramatically higher error rates for people of color or women compared to white men. This means the technology itself could perpetuate or worsen systemic discrimination. So this demands what we call algorithmic accountability. We need systems whose decisions can be explained, at least to some degree. That's the field of explainable AI or XAI. We need ways to audit algorithms for fairness, to check for bias.
And it gets even trickier with autonomy,
Right, oh yeah. It raises profound questions of autonomy and moral decision-making. If an autonomous vehicle is faced with an unavoidable accident scenario, the classic philosophical trolley problem, how is the ethical logic decided? Who decides? How is it coded into the system? IS professionals are literally writing the code that makes these kinds of moral trade-offs right now. It's a heavy responsibility.
Okay, privacy and AI bias. What's the third ethical area?
Third is the digital divide and equity. Technology has amazing potential, but it can also widen inequality if access isn't even. The digital divide the gap between those who have access to digital infrastructure like broadband, devices, and the skills to use them, and those who don't is a serious issue.
We saw that clearly during the pandemic, didn't we, with remote learning?
Tragically clear. Students without reliable internet access or suitable devices at home were put at a severe disadvantage. It highlighted how unequal access can exacerbate existing social and economic inequalities. So this raises a fundamental ethical question of justice. How do we ensure that the benefits of these powerful new technologies are shared broadly across society?
Yeah.
How do we avoid creating a world of digital haves and have-nots?
So IS strategy needs to think about equity.
It absolutely should. Designing equitable systems means considering things like accessibility for people with disabilities, affordability for lower-income users, and providing the necessary training and support required for people to actually benefit from the technology. It's not just about the tech, it's about equitable access and outcomes.
Makes sense. And the fourth major ethical flashpoint.
Fourth is job displacement and the future of work. This is a big looming question. Automation, robotics, AI, they're undoubtedly poised to fundamentally reshape labor markets.
Taking jobs.
Especially jobs that involve repetitive tasks, whether manual or cognitive. Many analyses suggest a potential hollowing out of middle-skill jobs, while demand might increase for very high-skill technical roles and maybe some low-skill service jobs that are hard to automate. This raises huge societal and ethical policy debates.
Like, who's responsible?
Exactly. Should companies that heavily automate have a responsibility to help retrain the workers they displace? If automation becomes widespread very quickly, does society need to seriously consider concepts like universal basic income, UBI, to provide an economic safety net? These are massive questions with no easy answers, but technology is forcing us to confront them. So given all these complex challenges, how do we practically integrate ethics into the day-to-day work of IS? We can't just wait for laws to catch up, we need to act more proactively.
What tools or frameworks can we use?
Well, there are ethical frameworks like technoethics, which emphasize core principles such as beneficence, doing good, creating positive impact, non-maleficence, avoiding harm, and justice, fairness, equity. Professional organizations also provide guidance. The ACM, the Association for Computing Machinery, has a detailed code of ethics and professional conduct that urges computing professionals to, among other things, contribute to society, avoid harm, be honest, respect privacy, and maintain confidentiality.
So there are guidelines.
Practically speaking, for IS projects, this means moving beyond just doing a technical risk assessment. We need to start implementing ethical impact assessments much earlier in the project lifecycle.
Like an EIA, similar to an environmental impact assessment.
Exactly like that, but focused on potential societal and ethical harms. It involves identifying potential negative consequences, consulting with diverse stakeholders, not just the paying client, and doing intensive scenario planning, thinking through what-if scenarios before major investments are made or systems are deployed. And here's a crucial point. Ethical demands often aren't just constraints, they can actually be drivers of innovation.
How so?
Well, the strong societal demand for user privacy is forcing the tech industry to develop better end-to-end encryption, new techniques like differential privacy to analyze data without revealing individual identities, and more user-centric data controls.
Okay, so privacy needs spur new tech.
Right, or think about environmental concerns. The push for sustainability spurred the whole field of green IT practices like optimizing data center energy efficiency, using renewable energy sources, designing for longer hardware life cycles. Ethics, in this sense, acts as a crucial boundary condition, pushing us to make technology not just more powerful, but fundamentally better, safer, fairer, and more trustworthy.
Okay, so we've covered the huge historical sweep, the paradigm shifts, the revolutions, the ethical minefields. Now let's bring it down to the practical organizational level. This is where the information systems field really comes in, right?
Yeah.
Because IS recognizes that technology never just exists in a vacuum.
Absolutely not. It has to be implemented, it has to be used by people working within organizational structures, processes, cultures, all hopefully aligned towards achieving some strategic goal. The whole IS field is fundamentally about mastering that crucial integration. And the foundational model for understanding this integration, something every IS student learns early on, is the People Process Technology, PPT, framework.
PPT, People, Process, Technology.
Right. It emphasizes that a successful information system is the balanced combination of all three pillars. And crucially, they're interdependent. A change in one pillar inevitably forces changes in the others.
Can you give an example?
Sure. Let's say a company implements a big new enterprise software package, like an ERP system technology. That's just the start. It will absolutely require extensive training for employees, maybe creating new roles, maybe even layoffs, people. And it will almost certainly necessitate re-engineering existing business workflows, changing approval chains, maybe adjusting performance metrics, process.
So you can't just focus on the tech.
If you only focus on the tech, you buy the shiny new toy, but you ignore the user needs, the organizational culture, the necessary process changes, the entire project is almost guaranteed to fail, or at least dramatically underperform. That's an IS failure.
Okay, let's try applying this IS lens, the PPT framework, back to some of the examples we've already talked about. Let's start with Kodak again.
Okay, Kodak through the IS lens. Their fall wasn't just a failure to see the future, it was fundamentally a failure to align people and process with the emerging digital technology.
How did the people and process fail them?
Well, their internal metrics, their reward systems, their entire strategic planning cycle process were rigidly fixed on maximizing chemical film sales and market share. The organization's culture, its identity, people, was deeply rooted in chemistry and manufacturing. They viewed digital not as an opportunity, but as a low-quality threat to their core business.
So a whole system was pulling in the wrong direction.
Exactly. Because the organizational system, the PPT alignment, was fundamentally geared towards the old paradigm, crucial information about the potential of the digital shift, even information generated internally, was dismissed or ignored by leadership. The technical invention was there, but the IS framework failed to integrate it strategically.
Okay, what about the Industrial Revolutions? Can we see the IS lens there? Like Henry Ford's assembly line.
Oh, Ford's assembly line is arguably one of the greatest IS optimizations in history. We often think of it just as a technological marvel, the moving conveyor belt technology. But it was so much more than that. It was a profound system redesign. Ford meticulously broke down the complex process of car building into hundreds of small, standardized, interchangeable tasks. Process. He trained workers to perform just one or two of these simple, repetitive tasks with high efficiency people. And then he used the conveyor technology not just to move parts, but to rigidly control the flow and tempo of the entire production system. He optimized the whole PPT system, not just the machine. And bringing it to today, in the fourth industrial revolution, that IS lens is absolutely crucial for things like governance, especially around ethics. Think about implementing GDPR compliance for data privacy.
Okay.
Achieving compliance requires robust technological controls, obviously things like encryption, strict access management systems, technology, but that's not enough. It also requires intensive ongoing training for all employees who handle data, people. And it requires establishing clear documented protocols for data handling, storage limits, breach reporting procedures.
Process. So it's all three again.
Absolutely.
Yep.
And when you see major ethical lapses, like big data breaches, they frequently stem from failures in the people or process pillars, maybe inadequate employee training, maybe a failure to consistently enforce data access protocols. It's rarely just a tech failure. It's usually a system failure.
That makes sense. And the sheer speed of innovation we talked about,
Yeah.
that must put huge pressure on traditional IS departments and their governance models, right?
Yeah.
Like employees using new cloud tools without asking.
Immense pressure. Employees are constantly finding and adopting new software as a service, SaaS tools, new apps, often without any formal IT approval. This is often called shadow IT.
Because IT doesn't know about it.
Right. Now, the old command and control approach might have been to just forbid shadow IT entirely, but the modern IS lens suggests that's often futile and counterproductive. Governance has to adapt. The IS professional's role shifts. You need to constantly scan the horizon for emerging technologies, quickly evaluate their potential fit with strategic goals, but also figure out how to manage the adoption pipeline, maybe creating sandboxes for experimentation, setting clear security standards for approved tools, integrating useful shadow IT into the official portfolio while still ensuring security, compliance, and data integration. You have to recognize that if users find a genuinely better, faster way to do their job, process, the old official way is probably dead anyway. You need to enable beneficial adoption while managing the risks. And this whole challenge of managing integration in a fast-changing world brings us to a few more key IS concepts that are really crucial for you as a learner to grasp.
Okay, what are they?
The first is the idea of socio-technical systems. This theory, which has been around for a while but is more relevant than ever, recognizes that when you implement new technology, it doesn't just automate a task. It fundamentally changes communication patterns, power dynamics, decision-making authority, social interactions within the organization.
It changes how people work together.
Exactly. So, good IS design isn't just about technical optimization. For example, making the database faster. It must optimize both the technical elements and the social elements. Example, how teams collaborate using the database, so they work in harmony.
Can you give an example?
Sure. Think about designing an AI recommendation tool for financial analysts. You need to optimize the accuracy of the algorithm, technical, but you also have to carefully design how those recommendations are presented to the human analyst, social. How much explanation is given? How is uncertainty communicated? The goal is to maximize trust, avoid cognitive overload, and ensure the human and AI work together effectively. That's socio-technical design.
Okay, socio-technical systems. What else?
Then there's the diffusion of innovations theory, most famously formalized by Everett Rogers. This theory describes how new ideas, products, or technologies spread through a population or organization over time, following predictable adoption curves.
Like the early adopters, laggards, that kind of thing.
Precisely.
Mhm.
You have the innovators who jump on things first, then early adopters, the early majority, the late majority, and finally the laggards. Understanding this is vital for IS professionals because you often act as the critical change agents trying to get a new system adopted.
So how do you use theory?
You need to identify those innovators and early adopters first. They're your allies, your pilot users. You work closely with them, get feedback, refine the system. Then, you strategically communicate the successful results, the benefits they achieved, to the broader group, the early and late majority. You need to reduce the perceived complexity of the innovation through clear training and support. And you need to increase its observability, make the positive results highly visible to others. It's about managing the social dynamics of adoption. And a third core IS concern, maybe the most fundamental from a business perspective, is ensuring the business value of IT. When you're evaluating any new technology investment, whether it's blockchain, quantum computing, a new CRM system, whatever the crucial question must always be, how does this investment align with our overall business strategy? Will it actually deliver measurable value, or is it just technology for technology's sake? A cool but costly upgrade.
That reminds me of something mentioned earlier, the IT productivity paradox.
Yeah.
That sounds related to business value.
Very much related. The IT productivity paradox was a major puzzle for economists and business leaders, especially back in the 1980s and early 1990s. Companies were spending billions on computers, servers, networks, massive investments in IT infrastructure.
Okay.
But when economists looked at the national productivity statistics, or even individual firm productivity, the gains just weren't showing up, or they were way smaller than expected. People were spending all this money on hardware and software, but seemingly getting very little bottom line return. Hence, the paradox.
So why was that happening? Was the tech bad?
Not necessarily. The technology itself was often fine, even powerful. The problem was that the complementary organizational changes needed to actually leverage the technology were missing.
Ah, the people and process parts again.
Exactly. Companies installed email systems, but managers still insisted on paper memos for official sign-offs, process failure. They bought powerful PCs for everyone, but didn't adequately retrain employees on how to use spreadsheets or databases effectively to change how they worked. People failure.
So just buying the tech wasn't enough.
Not even close. The core realization from studying the paradox was that buying the tech is often the easiest, simplest part. The real hard work that unlocks productivity gains comes from re-engineering the business processes, changing the workflows, maybe decentralizing decision-making authority now that information is widely available, and intensively training staff changing the organization to take full advantage of the new IT capabilities. The paradox taught us definitively that IS is about holistic organizational change management, not just technology procurement.
Okay, that's a powerful lesson. Let's try to pull all this together with a concrete, practical example, maybe something from healthcare, like a hospital adopting a new electronic health records, EHR system. How would the IS lens apply there?
An EHR system adoption is a perfect and often very challenging real-world example of IS in action. It's a massive undertaking, often a paradigm shift away from decades of paper charts.
So how does the PPT approach work?
Well, the IS approach goes way, way beyond just installing the EHR software technology. First, it involves intense consultation and collaboration with the end users, the doctors, the nurses, the administrative staff, people. You have to deeply understand their highly specific, often complex, and heavily regulated workflows before you design or configure anything.
Got to understand the users.
Then, you customize and configure the EHR system technology to ensure it meets not only those user needs, but also all the relevant legal and regulatory mandates, like HIPAA privacy rules. Then comes the rollout. You need careful planning, often a phased approach, with detailed change management strategies, process, to minimize disruption to critical patient care during the transition. Training people is absolutely critical and ongoing.
And it doesn't stop at go live, right?
Not at all. Post-deployment, the IS team continually monitors system usage, gathers feedback, tracks key outcomes like efficiency gains or error reductions. And, crucially, if doctors start complaining that the interface is clunky, or if nurses start using informal paper workarounds because the system is too slow, basically creating shadow IT within the hospital.
What does the IS team do?
A good IS team doesn't just blame the user, they're resistant to change. They treat that as valuable feedback signaling a failure in the socio-technical system. They investigate the root cause. Is the interface truly bad? Is the training insufficient? Is the network slow? Then they work to refine the system, technology, improve the training people, or adjust the workflow process to address the actual problem. It's this continuous cycle of aligning people, process, and technology, that complex socio-technical balancing act that is the core professional value the IS expert brings.
Okay, I see. So ultimately, the IS professional is kind of the bridge builder, the translator.
That's a great way to think about it. You need to be fluent in the language of business understanding, strategic goals, ROI, market needs, viability. You need to understand the language of technology, what's possible, what's feasible, the limitations, feasibility, and you absolutely must understand the language and needs of the end users, the people who actually have to use the system every day, desirability.
Balancing all three.
Your role is to integrate these perspectives, to prioritize investments based on that balance, and to manage the complex process of technological transformation in a way that's ethical, efficient, and actually delivers sustainable strategic value to the organization. #tag outro. So we've taken quite a journey today from, ancient stone tools all the way up to the exponential velocity of this fourth industrial revolution we're living through.
Yeah, quite a sweep.
We saw how innovation, which used to be measured in centuries, is now accelerating at this unprecedented rate, driven by global connectivity, digitalization, compounding knowledge. Technology is clearly the engine driving society forward. But its immense power means it absolutely must be steered with wisdom, with foresight, and with ethical consideration.
And we really tied all of that back to our opening story, didn't we? That incredibly rapid arc from a fragile 12-second flight at Kitty Hawk to a giant leap onto the moon just 66 years later, that kind of dizzying pace of technological change, that's now the baseline expectation in pretty much every industry.
It's the world you're entering.
Exactly. And to succeed, to thrive in this environment, you absolutely have to adopt that information systems lens. You have to master the crucial integration of people, process, and technology. That's how you become not just a participant swept along by this change, but a thoughtful, ethical shaper of it. Now, before we wrap up, please, if you found these concepts useful, remember to like, subscribe, and share this deep dive. It really helps get these ideas out there.
It does.
And don't forget, All the references from Dr. Schuessler's text, plus links to other helpful resources, are right there in the description below.
And maybe as you go about your week, as you face the opportunities, and yeah, the uncertainties of this fourth industrial revolution, here's a final thought for you to mull over, grounded firmly in that practical IS lens we discussed. How will you, in your future career, manage that inevitable organizational inertia? How will you build the case for making the necessary, maybe difficult strategic shift, maybe even that painful cannibalization, before some disruptive competitor forces your organization's hand? Something to think about.
That's a wrap on this episode of Emerging Technologies and Innovation Strategy. Keep questioning, keep exploring, and remember, every disruption starts with curiosity. Until next time, stay ahead of the curve.